Hey bio students, we are going to talk about cladograms of animals today. So the last couple of days we talked about introduction to animals. We talked about the characteristics, invertebrates versus chordates. We also then talked about, Mr. Dean talked about body plans with you. Today I'm going to talk about cladograms and what exactly a cladogram is. So a cladogram, when you think of an animal, let's first think about this. When you think of an animal, what do you think of? I'm sure you probably all think of organisms actually in this column. You're going to think of dogs, cats, fish, your sibling. That's what I think of when I think of animals. But animals are more than just creatures with a backbone. They have a whole bunch of other characteristics as well. There's the starfish and a snail and flatworms and grasshoppers and arthropods and things like that. So we're going to talk about how we can organize and how this is organized in this cladogram. So here is just a larger picture of what I had just shown. So how is it organized? A cladogram shows the relationship between organisms. It shows animal phyla. In our case, it's showing the animal phyla based on their body plans and patterns of embryonic development. So with Mr. Dean yesterday, you had listened to his video about body symmetry, germ layers, embryonic development, segmentation, things like that. But we're going to now put that into this cladogram and organize it so that they're organized in different categories on how you can see on how they were formed or who they're most related to. Oh, and I just lost my mouse. There we go. This information is all that we learned yesterday. This is what I just said. We can then visually compare different organisms. They can be super small, like what I had just shown you in the slide before, or it can be very large and complex. Cladograms are like a whole bunch of different ones, and I'm going to show you one real quick. Here is comparing whales to a whole bunch of different other mammals, and super detailed, right? Obviously, we're not going to cover this, but I just wanted to show you that some of them are super simple, comparing simple things. Others can get super complex and strung out doing the different characteristics and different relationships between those. So how do I read it? Great question, right? So the root is the start. So our start is multicellular. We learned, right, in Helm, heterotroph, eukaryotic, laxocell wall, multicellular. So we're all going to start. We're going to start at the root, and we're going to start. They're all multicellular. And what happens next is you're going to go through, and each dot is something that a change happens. And then they're branching off. So we see this jellyfish right here. So we can read through. It's multicellular, tissues, it has 2 germ layers, and has radial symmetry. Learned about symmetry yesterday, right? Whereas compared to this the grasshopper, it's multicellular. It has 2 germ layers. Well, actually, if we continue on, it has organs, 3 germ layers, bilateral symmetry, and we continue, protozome, and it has segmentation. So you can read through comparing the grasshopper to the jellyfish, and then comparing it to fish or the cow over here that has backbone, also has segmentation. So these dots can be reused, obviously, or segmentation can be, or other characteristics can be put on different parts of the graph as well. So this shows the variations of the body's basic plan and how they might have evolved. Who might be your closest ancestor? And the nodes represent common ancestors between those species. At some point in the past, a population of common ancestors were divided among, right? So each node is something that is that split. It's that branch off into something different. Some cladograms show extinct, I was researching, and some cladograms show extinct organisms and species. Okay, so let's do this together. I actually just snipped this from the internet. But in this following cladogram, which of the following groups are most closely related? So I took something a little bit simple so that we can compare it. So how do we know who is more closely related? We can see here that flies and moths are actually the most closely related, because flies and beetles are actually many branches and many nodes apart. So we aren't going to say that flies and beetles are. Beetles and ants, there's a lot of branches in there. And we said flies, so we can say that flies and moths are actually the most closely related. Okay, so this is going to be your first question in your quiz. So what trait does roundworms have by looking at the cladogram? So we're going to find a roundworm. Here's a roundworm right here. So we read through, we're going to see that they are multicellular, they have organs, 3 germ layers, bilateral symmetry, protozoan, and then they're not segmented. And you can see in this chart that I also cropped in that this is pretty true, right? They're not segmented. They have 3 germ layers, they're bilateral symmetry. You can figure out what a roundworm looks like by looking at this cladogram. So this is what I snipped from our textbook, and it's included as well in the pages below. So I'm now going to have you do this on your own and figure out what characteristics and what traits do some of the organisms have. I'll make sure to label them so that you can see them. Let us know if you have any questions. Happy learning.